a software engineer at Google. I work on the Chrome team. And I'm going to be talking about WebAssembly today. Just by show of hands, who's heard of WebAssembly at all? All right, everybody has heard of it. Who's actually compiled something to WebAssembly? One person, yes, excellent. Okay, that's what I wanted to hear. Okay, so this is our logo. We actually had a fun logo contest. This is the one we ended up with. You can't see here, but the reason it's got that little notch in the top is because JavaScript is supposed to be on top. And it's actually the complementary color as well. The idea being that WebAssembly works together with JavaScript. So just as he was saying, it's not about replacing JavaScript, it's about working with JavaScript, sort of supporting JavaScript. So the tool that I primarily work on for WebAssembly is called Wabbit. It's kind of a fun name. It stands for the WebAssembly Binary Toolkit and does a number of different things, converting to and from the WebAssembly text and binary formats, and has an interpreter. It has a number of different tools that you can use to explore the WebAssembly format. So what I'm going to do for this talk is talk a little bit about WebAssembly, the module format, talk about some new languages that you can use with WebAssembly, and then I'm going to talk about the future of WebAssembly. So for some of the basics of WebAssembly, this is a really great talk. Sorry, it's not a talk, it's an article by Lynn Clark of Mozilla DevRel team. She did a nice cartoon intro to WebAssembly. There's, I think, 7,500 words. It's like very long, but interesting because it's got nice pictures. She talks a lot about assemblers and just-in-time compilers and all the sorts of things that will help you understand what is WebAssembly, why is it fast, and why would you care? But I'm not going to really talk about that. The one thing I am going to steal is I love this art style, so I'm going to steal that for the rest of my talk. There we go. So, interesting thing about WebAssembly actually is that it's got kind of a silly name. First of all, it doesn't really have anything to do with the web. It's more of an executable format. So, also, it's not really an assembly language, it's more like a binary format, so it's kind of a silly name. But it works and it's nice, and so we're sort of stuck with that. Okay, so the WebAssembly module overview. I'll go into it now. So there's your module. Okay, so basically the idea of the module is that it's just a container for everything that goes into a WebAssembly executable. Think of it like being an exe if you run Windows, or well, I don't know what you call them on Mac. But yeah, it's just the container for everything that goes inside the executable. So the most important thing that goes inside is functions. This is primarily the thing that will take up the most space in a WebAssembly module. And this is what some of a particular function might look like. This is some of the assembly code, and I know you can probably not read that on the side, but this is actually a factorial function. And it's the full function, and it operates on 64-bit integer types. So, yeah, a function. So obviously functions can call other functions inside the module, just like any other function. But you can also import functions from outside. So that's kind of what I'm trying to get at here, is that you can call something else. So what you might be importing from is from JavaScript, in this case. So another thing that a WebAssembly module has is memory. And you only have one, because you only need one. And it sounds a little bit weird, right? Because for JavaScript you have a bunch of objects, or if you are accustomed to writing a lot of languages, you'll see that you normally have a number of objects. In WebAssembly, what you have is actually just one piece of memory that has a lot of bytes. It's just raw data. And you sort of think, well, what can you do with that? Well, actually, you can do quite a bit. Everything that you have, all of your objects, basically get put into this data. So if you've ever written something like C or C++ before, the stack goes here, the C++ stack. If you allocate memory, the heap goes here. Even static data goes here. All data goes into the memory here. So obviously, your functions can read and write to this memory. That's primarily how you interact with it. The other thing you can have is globals. But actually, I'm going to take a step back here for a second. So the reason that you have this, you're probably looking at this and saying like, well, okay, what is this all about? What's the purpose of what you just showed me? The purpose is, think of this like a module, like you would have for JavaScript. You can import it and provide these pieces of functionality. We haven't gotten to it yet, but the idea is that eventually you will be able to access these functions. All right, I'll get to it. So another thing that you have inside a WebAssembly module is globals. And the idea of the global is that it's a way to store some data that multiple functions want to access, but you can also pull from outside of the WebAssembly module. So in this case, you might store, say, a stack pointer inside a global. Or you can store any value, actually. You can store any number of globals here. And obviously, a function can read and write to the globals as well. There's something actually a little bit special about this, though, because the current implementation does not allow you to write to an imported global. That's a current limitation. We will likely be reducing that limitation in the future. Okay, so the next thing you have are tables. Tables seem like they're not super useful, but really what they do is they allow you to store a reference to a function. So the idea is that one of these functions, say this one here, might be referenced here. So you can have a big table of functions, and the only reason you have that is that you can do indirect calls. So if you've ever written C++, this allows you to do something like virtual functions. Be able to call into a table, hit a reference, and then call back out. Very useful for being able to provide an abstract interface to your code. And then exports. So the idea here is that finally we have this module. For the longest time it's been self-contained. It couldn't do anything. It's sort of like just a black box. Finally, when you have an export, what you can say is, okay, I've got these certain things inside my module. I want to export those to my embedder, in this case JavaScript, and allow them to call those functions, allow them to use those functions. So what you can see here in the little purple boxes, I've exported these two functions here, and I've exported this global as well. These are all things that are now I can give to my JavaScript function, and I can say, call this. So again, if I go back to the function here, you could say, I have this factorial function. Factorial is kind of a dumb function. No one really actually needs a factorial function normally. Basically, it's the one that you can multiply all the numbers down. Okay. Anyway, it doesn't really matter. But the point is, imagine you want a really, really fast factorial function. Well, you could build it inside your module and then export it here. So the idea is that now you have your WebAssembly module that's contained inside JavaScript, right? So this is sort of where everything gets wired up. You can see on the left side, that's the imported functions and the imported global that is imported into the WebAssembly module. Then the WebAssembly module exports those functions to JavaScript, and then JavaScript can use it. So it seems like kind of a pointless thing, but really what you've gained here is this self-contained unit. And the WebAssembly unit allows you to do something that you would have trouble doing in JavaScript. The idea is that JavaScript is actually written in such a way, typically, that it's very hard to optimize. Because any piece of code could do a number of different things. For example, if you say A plus B, well, if those things are numbers, then you add them. If they're strings, then you have to append them. If they're an array, then, well, I don't know, I'm sure you know what it does, but I have no idea what it does. JavaScript is very complicated in that regard. The nice thing about WebAssembly is that everything is very low level. So the idea is that all you have are numbers. So when I say add two numbers, well, there's no guesswork. You say add the two numbers. And that operation is something that you could already do in your hardware. So the mapping between what WebAssembly does and what your hardware ultimately does is almost one-to-one. That's the reason why you get a lot of optimization there, is because you don't have to do any guesswork. Your JavaScript engine doesn't have to do anything clever. So let's move on to some of the new languages that are possible with WebAssembly. And actually, they're not really languages. They're more like compilers. Because currently what people are doing is they're taking languages that they've already implemented, that already exist, and they're trying to figure out ways to make them work for WebAssembly. So this first one is actually very interesting. It's called TVM, and it's been around for a little while. And what it does is it takes Java bytecode and it compiles that to JavaScript. And there's an experimental backend that allows you to compile that to WebAssembly. And so what this is what's really cool about this is that it allows you to take code that you would have written in Java, which you can obviously use to write Android apps or server applications or anything, and then bring that to the web. Because you can choose between JavaScript and WebAssembly, now you can support browsers that don't necessarily support WebAssembly yet, or you can support browsers that do, and it's very likely that you'll get better performance. Actually, on his website, he has some benchmarks that show some of this. Very, very cool. Another thing that's very interesting about this is because it's using Java bytecode as the mechanism for converting, you can also support languages like Scala and Kotlin. So any Java bytecode language could be supported. Another one that's very interesting is a newly developed language called TurboScript. And what's interesting about TurboScript is that it's actually written in such a way that it looks very much like TypeScript. And the developer of this language sort of forked from an original experiment called ThinScript when we first started developing WebAssembly, and made some changes to it. But he has what amounts to a very interesting pipeline, which is because the compiler is written in TypeScript, you can actually compile in the browser. And he has a very cool demo where you can see that. Maybe I should have showed some of those demos. Oh well. But the point is that you can actually take code that's written in what looks very much like TypeScript, and you can compile it to WebAssembly, and you can run it directly in the browser. And so this, of course, also means that you could take that same code and run it via NPM in Node, and use that to get a nice performance boost. That's the premise there. And the reason it's got this logo here is because I guess the logo is a snail. I did the colors though. That was my choice. This one's got a lot of text. This is a very interesting experiment. by a person named Misha Reiser. And the idea is that you can take something that looks very much like TypeScript, and it actually is TypeScript. It uses the TypeScript compiler, but you annotate certain functions, and you say, with this useSpeedy.js, you annotate the function and you say, I want you to compile this in a different way. And what it does is it takes this code and it actually parses it, converts it to an LLVM representation. LLVM is a very popular compiler backend. And then it uses the LLVM's backend to convert it to WebAssembly code, which is what I've drawn in very, very tiny font on the right there. And so what's very cool about this is that now you can take your TypeScript code, which maybe there were certain components of it that were running a little bit slower, and all you should have to do is annotate that and say, trust me, I want this to run fast. And then it will convert it to a very low-level code that will just run faster for you. It's very, very cool. He started this experiment, I think, only just a few months ago. So it's still very new, but pretty interesting. Okay, so let's talk about the future things that you might see with WebAssembly. So currently with WebAssembly, we support languages that look very much like C and C++ and Rust. So probably languages that, I mean, does anyone here use those languages on a regular basis? One person, okay. Right, they're not the most popular languages, and that's because if you're writing code for the web, they don't really work very well. One of the reasons why WebAssembly is not super interesting to people just yet is because it only does support languages like that. It has to be something that's very statically typed. It has to be something that doesn't use garbage collection. It has to be something that is pretty low level. And so what's cool about some of these new features is that we will be able to support new languages, more than just what I talked about here, but potentially languages like Elm, potentially languages like OCaml, languages like TypeScript but supporting it fully. Any number of front-end languages we should be able to support, and what will be great about that is that you would be able to actually get a performance boost, because now, rather than compiling to JavaScript and then sort of hoping that your JavaScript engine performs well, you can actually look at the code and say, well, this is exactly what's being generated. It's not going to do anything clever because I don't want it to. So garbage collection is one of the best things there. Exception handling, again, kind of a no-brainer, right? But you can't currently do it in WebAssembly. This is like being able to throw and catch exceptions. So being able to integrate that directly into WebAssembly means we'll get a much better performance boost. You can currently do it, it's just it ends up being sort of a little bit slower and lower level. SIMD. SIMD is a complicated topic, and I won't go into too many details about it, but the basic idea is that your computer actually is mostly only doing one quarter work a lot of the time because you're only doing operations on one value. Your computer is sort of set up in a way that it wants to operate on many values at the same time, and that's what SIMD is. So if you can tell your computer, like, oh, by the way, I'm operate on 4 things at a time, then you should be able to get quite a bit of performance boost. And so actually we're going to have a CG meeting, a community group meeting in the United States, in California next month, where we're going to talk about some of these issues. And so if you are particularly interested and dedicated, you could fly out and join. And threads and atomics are actually one that's near and dear to my heart, actually, because I've been working on a proposal to add threads and atomics to JavaScript as well. And so what's great about this is that it's sort of another one of those no-brainers when it comes to computers, right? Like the computer that you have, even in your pocket, usually has multiple cores. Often those are being used to run different processes, but why not allow them to be running the same piece of code? If you have very high performance code that you want to have running on your phone or on your computer, then you can't currently do it in a page. It's not really possible. So one of the things that you can get out of adding this to WebAssembly is now you can create another thread and you can run things in the background. So one of the things that you currently have to do in JavaScript quite a bit is you have to yield to the event loop. You call to a function that says, "I'll tell you later when I'm done." When you have threads, you can actually do it in a much different way. You can just block. You can say, you know what? I'm going to wait here until I'm done. Then you can give me my results, and then we can keep going. And that's a much different model, but it has its own benefits. So some pretty exciting stuff that we'll be able to do in the future with WebAssembly. And that's all I've got. But I also would love to have questions, because I imagine that I realize now that I probably did not explain maybe some of the simpler stuff as well as I could have. So if there are some questions, I would happily have them.
Well, let's give Ben a hand.
Yeah.
We did have a question over there. Yes. No? You? Yes, indeed.
I can go first?
Yes.
Yeah,
Wait for a mic.
Oh, okay, cool. Thanks for the talk.
Thanks.
So the question is, because there used to be technology called Flash, and killed by Adobe, no, by Apple, and then I'm thinking like, okay, you as Google are doing this, but that reminds me of Flash so much, and then what's the kind of, it's gonna be, do you see like issues when it comes to mobile devices when, you know, people, certain manufacturers will start blocking it or would not fully support it as a, you know, as a kind of runtime environment?
Yeah, so that's a great question, and actually it's one of the probably the things that I should have led with was that actually what's very interesting about this technology is that we've been working together with other browser vendors to ensure that everybody is on board. So currently it's supported in Chrome and in Firefox. It's behind a flag in Safari, it's in Safari Technology Preview, which is where they sort of demonstrate a lot of their new technologies, and it's behind a flag in Edge. And at all the meetings, we meet regularly with people from Apple and people from Mozilla and others. And like I said, the community group, we're also meeting with Intel and ARM and MIPS and everybody to try and make sure that everybody is happy with what we're producing, and it doesn't end up in a situation like Flash where people say, well, we don't want to support it.
So we had another third question here.
Yeah, so my question is just that you said that you can compile TypeScript and the like to WebAssembly, yet you don't support exception handling and so on. How do you deal with that?
Yeah, that's a good question. So we don't support what we call zero-cost exception handling. And it's a bit of a technical distinction there, but the idea is that you can support exception handling by calling out to JavaScript and then calling back into WebAssembly. And JavaScript, and then anytime you want to throw an exception, you call back out to JavaScript and you throw, and then it gets caught in JavaScript at a higher point in the stack. And then, do you see how that makes sense? Well, if you do, then awesome. But yeah, the basic idea is that you can support a lot of this stuff, and you can support garbage collection too. Like when I was showing you that slide about how memory is laid out, you can do garbage collection in memory like that. It does work, it's just that it's not as fast as you might like it to be. So people have already taken Python, for example, compiled it to WebAssembly, and you can run it. You can currently run it in the browser. The problem is that it's slower than Python already is, right? Because it doesn't have the functionality to do some of the things that would be able to make it fast. So what we're going to do is add some of that functionality in the future, and I think that's the thing that people are really excited about. As soon as we add like first-class garbage collection to WebAssembly, now you can support languages like TypeScript more directly.
Okay. One final question.
So like,
you said that WebAssembly is not a language, it's not an assembly, it's not an interpreter. So for me, it's not super clear what WebAssembly is right now. But maybe that's not the question. Like, can you tell me in 2 years what am I gonna do with WebAssembly? How am I gonna use a module? Like, what a module is gonna be? Is it gonna be something that like a library that I already find in the user browser, and I don't have to send through HTTP, or what's gonna do for me?
Yeah, no, that's, yeah, again, probably should have led with this for the next talk. So what I would say is that, yeah, the important thing is that you probably won't, if you're a typical developer, you probably won't even need to use WebAssembly. Because a lot of times, what will happen is someone will make a library that you use, and they think to themselves, well, if I make this into a WebAssembly library, then it'll be faster. And they do that, and you use the library, and you call the functions, and you don't know how it works at all. You don't really care, because it's faster. So that's one way that that you might use WebAssembly in the future, is that you just get a library, and now it's fast. You can do, let's say, face recognition on client side, because it's fast enough that you can do that. Another way that you might see that people use WebAssembly is what I was describing here about new languages. It might be the case that you'll be writing in a language that compiles to WebAssembly. So again, maybe you don't care as much that it does that, because you care more about the language. But what WebAssembly has done is it has enabled you to be able to use that new language, because normally all you can use is JavaScript, right? If you're writing client side. So, so yeah, I guess that's how I might answer that question, is that it's probably going to work best when you don't even notice that it's there.
Okay. Let's give Ben another hand.